This is video number 5 on solving equations, and on this video we're focusing in on equations that have fractions. So we've talked about fractions in, I think, the second video, where you had something like x over 2 equals, let's say, 3, right? There's a fraction. Whenever you have a fraction and you want to get rid of it, all you have to do is the inverse operation, which is multiplication, right? A fraction is really a division problem. What this really says is a number divided by 2 equals 3. So this divided by 2, if you don't want this fraction, that you don't want the divided by 2 part, go ahead and do the opposite, the inverse operation, which is multiplying by 2. And of course, what you do to one side, do to the other side. That does cancel out. So we end up with x equals 6. And like I said, we've done this on the second video. We dealt with these simple fractions. We even dealt with like a fraction that was like 2/3 x equals 4. And we solved that one with a two-step process by multiplying by 3, multiplying by 3. That way the fraction cancels out. You're going to end up with 2x equaling 12. And that's really a 2 times x equaling 12. So you're going to divide by 2, giving you x equals 6. So that's stuff that we've done before on the second video, I believe. Let's look at one that's a lot more entertaining. What happens when you have more than one fraction? When you have more than one fraction, I know this looks crazy. There's 4 fractions here. And you have options. You could get rid of one fraction at a time. Like if you wanted to get rid of the 1/4, you could multiply everything by 4. I'm talking this times 4, which will cancel out. This times 4, which you end up with 20 over 8, that could be reduced. And then this times 4, this times 4. Everything times 4, that'll get rid of this first fraction only. Okay. And then you could get rid of the other fractions by multiplying everything by those denominators. However, for the sake of time and for the sake of being the most effective problem solver, we're going to show you the best way to get rid of all fractions at the same time. Instead of getting rid of them one at a time, we're going to identify the LCD. We dealt with the LCD earlier in the class, back when we used to add and subtract fractions. If you're able to identify the LCD, you could multiply everything by the LCD and it'll make all fractions disappear at the same time. So how should we find the LCD? How do we go about that? Well, go to the biggest denominator and ask yourself, could you change the other ones to become that one with multiplication? 6 times 2 is 12, so 12 is looking good so far. 4 times 3 is 12. So 12 is looking good so far, but 8 times 1 doesn't work, 8 times 2 doesn't work. So 12 is not your LCD. Now, if this would have been, let's say, a 2, then yes, 12 would be your LCD because 6 could be changed to a 12, 2 could be changed to a 12, 4 could be changed to a 12. But 8 is what's messing it up right now, so 12 is not the LCD. So what do we do next? Well, if the biggest denominator didn't work, then try doubling it, right? What's 12 doubled? That's 24. Could you change the other ones to become 24? Yeah, 6 times 4 is 24, 8 times 3 is 24, and 4 times 6 is 24. So we have discovered that the LCD is 24. And if we multiply everything by the LCD, you could get rid of all fractions at the same time. Once again, if you multiply everything by the LCD, it'll get rid of all fractions at the same time. So we said the LCD was 24. So if we put times 24 right here, times 24 over here, times 24 right there, and times 24 right there, it'll get rid of all fractions at the same time. Let's start with this one right here. One option is to multiply 7 times 24, get a huge number, and then divide it by 12, but that's not the smart thing to do. It's a lot easier to divide first. 24 divided by 12. 24 divided by 12, that's 2. And of course, 7 times 2, that is a 14. And don't forget about the plus sign, that comes down. So you have a positive 14 right there. Next, we have 24 up here divided by 6 on the bottom. That is 4. So what do we have left? We have the negative 1x times 4. Negative 1x times 4 is negative 4x. Okay, and then we're going to bring down the equal sign. And then on the left side, 24 divided by 4 is 6. So put a line through there, put a 6 up here. And then you have 6 times negative 1x. 6 times negative 1x, that is negative 6x. And then we have 24 divided by 8, that's 3. And of course, a positive 5 times 3 is a positive 15. So voila, same equation, but now it has no fractions. How do we get rid of all fractions at the same time? By multiplying everything by the LCD. How do you go about finding the LCD? Go to your biggest denominator, see if you could change the 4 to become 12, the 6 to become 12, and the other number to become 12. If that's the case, then multiply everything by 12 because 12 is your LCD. If this would have been a 2, then 12 would have been the LCD. But the 8 doesn't work, right? So you have to change the, you got to double it then. So double it and it becomes 24. And then realize that you could change all the other ones to become 24. If it wouldn't have worked, you would triple it to 36 and see if all the other ones could change to 36. Anyways, we got rid of the fractions. Let's keep going. This is like the previous video that we have variables on both sides. So let's get the x by itself on one side, okay? We have x's on both sides. I want to get rid of the, you know what? I've been moving things to have positive x's. I'm just going to move the 4x this way, even though I end up with a negative x. So I added 4x, negative 6x plus 4x, that's a negative 2x. Bring down the plus 15, bring down the equal sign, bring down the 14, and let's continue solving here. We're going to subtract 15, subtract 15. What do we end up with? We end up with the negative 2x equaling 14 take away 15 is negative 1. And that's really saying a negative 2 times x equals negative 1. So for my final step, I'm going to divide by negative 2, divide by negative 2. That cancels out. My answer is x equals, you can't divide 1 by 2. That's going to stay a fraction. But you could realize that a negative divided by a negative is a positive. So the answer is x equals positive 1/2. X equals positive 1/2. So again, I hope this helps. Multiplying everything by the LCD will get rid of all fractions at the same time. The trick is to be able to find that LCD. So again, I want to repeat myself for like the 15th time. How do you find the LCD? Go to your biggest denominator, see if you could change the other ones to become that biggest denominator. If it doesn't work, double it, then see if they could all change to become 24 in that case when you double it. If it still doesn't work, triple it. 12 times 3 is 36. See if all of them could change to 36. Obviously, when you double it, 24, it works. So that's why the LCD was 24. Here's another example. This was straight from one of our worksheets. And we have a bunch of fractions. And of course, you want to get rid of all fractions at the same time by multiplying everything by the LCD. So how do we do that again? You go to your biggest denominator and see if you could change the other ones to become that one. So the biggest denominator is 8. Could you change 8 to become 8? Of course, it's already 8, right? You don't have to mess with it. Could you change 2 to become 8? Yeah, 2 times 4 is 8. So the LCD is 8 because 2 times 4 is 8. So it's even easier than the previous one, right? Once you identify that your LCD is 8, then you can multiply everything by 8. Now, what if these would have been 3s? Let's just for a quick second pretend that you would have had 3s down there instead of 2s. Then you would try to change 3 to become 8 and it wouldn't work. So then what? Then you'd have to double it. 8 times 2 is 16. Could you change 3 to become 16? No. Then triple it. 8 times 3 is 24. Yeah. Could you change 3 to become 24? Yeah. 3 times 8 is 24. So the LCD, if it were 3 and 8, would be 24. But it's not 3 and 8. It's 2 and 8. And you could change a 2 to an 8. So the LCD really is 8. So go ahead and multiply everything by 8 times 8 times 8 times 8 times 8, everything by 8. And notice that I'm putting the 8s up here on the numerator spot, not down here. Because if you actually wanted to, you could multiply 8 times 1 is 8, divided by 2, that'll give you a 4. Okay. Or you could just cancel it out. 8 over 8 cancels out. What do you have left? You have a minus 5x. So bring that down, minus 5x. Bring down the equal sign as well. And of course, 8 cancels with 8. What do we have left? We have a 7x. 7x. And over here, you could go 7 times 8 is 56, then divide by 2 and get your answer. But it's a lot easier to divide the 8 by 2. 8 divided by 2 is 4. And 7 times 4 is 28. So bring down the plus 28. You see, we got rid of all 4 fractions at the same time by thinking about what the LCD is. And how did we go about that? Once again, go to your biggest denominator and see if you could change your other ones to become that biggest denominator. If you can, like you could right here, 2 times 4 is 8. You're not actually going to multiply 2 times 4, but because you could change 2 to become 8, your LCD is 8. Multiply everything by 8, it'll get rid of all fractions at the same time. And of course, you just continue solving from there. So I'm going to add 5x to move it to the right side. Now, why did I do that? Because I had x's on both sides. I don't want x's on both sides. I only want x's on one side. So what do I have left? I have a 4, an equal sign, a 12x, because 7 plus 5 is 12. And we also have a plus 28. So I moved my minus 5x, I moved it to the other side by doing the opposite of minus 5x. What I do to one side, do to the other. And now I only have x on the right side. All I need to do is get it by itself. I don't want the 12, I don't want the 28. I need to get rid of both of them. Which one do I get rid of first? X is what's important. 12 is kind of important. 28 is not. Get rid of that guy first, right? So subtract 28, subtract 28. We're going to end up with a negative 24 equals 12x. And that's really saying 12 times x equals negative 24. So you're going to get rid of this multiplication of 12 by doing the inverse of multiplying, which is dividing by 12 and dividing by 12. So our final answer here is negative 2. So we have negative 2 on this side equals x. That's the answer, but of course it looks nicer if you say x equals negative 2. So I hope this helps, guys.